All right, is everybody ready? 8:30 in the morning. I'm so amazed that there are so many people here. I thought I was going to be presenting to an empty room, so I'm proud of you. Good job, everybody, for showing up. All right, so today we're going to be talking about essentially like the devolving malware landscape, which is kind of a ridiculous thing. I'm Richard Wartell. I feel like I've picked the perfect bio picture that tells you everything about how much of a consummate professional and wonderful human being that I am, which is this. I hope this works for everybody. I'm not going to elaborate on this whatsoever. This is me. This is me as a professional. And now I'm done with my bio slide, so I'll hand this off to Tyler. Oh, sure. Hello? Oh, that also works.
Deep voice.
Nice. Tyler.
You can just, that's me.
Tyler Halfpop is a computer. All right, we're done with bios. Let's keep going. So, first I'm going to kind of go over like where the genesis of this talk comes from, like why this is worth talking about. So, we're calling this section like a brief history of shenanigans, like kind of what's happened in hacking in the past. So, this is what hacking used to look like. Essentially, hacking used to be really damn easy, and apparently you can wear ridiculous outfits, and yeah, it was great. But this is actually like Hackers the movie is actually based on like this era in hacking called the Freakers era of hacking, and things were awesome back then because things were easy. So what happened back then is like, hey, there's like a server somewhere and it's got cool stuff, and you're like, hey, I want your stuff. What's going on there? And the server's like, hey, can I have your stuff, server? And the server goes, oh yeah, I don't know what you want, but like here, like just have a shell, figure it out. And that's how hacking went with it. Like that's how the Freakers era was. It was very much this like ridiculous era of like nothing was secured. Security wasn't a thing. So it was basically just like people poking things on the internet, and you just found things and like had fun with it. So then security happened. This is a good image of what security is, if you don't know. But basically, because of this, like people finally figured out, oh, like we should like protect our things. Like you can't just like leave things open on the internet and let people access them. That ends badly. You'll have people randomly poking them, breaking things, accessing things that they shouldn't. So security happened. This is maybe like a better generic image of what security looks like. But in general, this is when like the evolution of security began. However, we're going to continue in this whole talk basically talking about security and security vendors, and we're also going to be talking about hackers and malware authors. And it makes life easier if we kind of introduce these as characters. Rather than like talking about them and being like, and then the hackers did a thing, let's just like make a character for them. So for security, we're going to use Securite. For any time that we're referencing security, like or security vendors, like AV products, any of that, that's all Securite. And then because we couldn't come up with anything where we were like, this is the perfect, we're just going to go with Voldemort for hackers. I hope that's okay with everybody. And we're just going to run with that. We'll see what happens. It's going to be slightly ridiculous if you can't tell. So, essentially, let's get back to our story of like what was going on back then. Essentially, Voldemort had to get more clever. Like security products started getting introduced, so he started like actually introducing malware. It wasn't the days of just like randomly hitting things over an IP and having shell access to everything. Those kind of went away as security evolved. So now he had to start writing malware. So Voldemort started thinking about how to write malware and the things that he could do so that he could persist and maintain access to systems. Also, this is like my new favorite icon for malware, by the way. Like little dude hidden in weird Trojan horse, like super awkward. So Voldemort was thought about things, and he came up with worms. Like this is back in the day, the like old school version of malware, which is just meant to propagate. It was all of these pieces of malware that are just spitting over the internet, trying to get everywhere that they can. Original ones were basically existing just for like almost cred, like just trying to propagate as much as possible so that you could say like, oh, my worm's better than yours, it's everywhere. And then Voldemort even got better. He started saying, all right, what about like rootkits and botnets and ransomware? I can do all of these things. But Securite doesn't mess around. So like Securite was like, all right, I got this. And then like the evolution of AV products happened. She spits out all of these AV products, basically creating signatures, like making things where little bits of things that are part of that malware that she can say, all right, we got this, we can block this. We know something about this and we can block it. So Voldemort is like, all right, I got to get more clever. I got to evolve. I got to do better things. So Voldemort is like, all right, my old malware, it's not working anymore. I don't know what to do. Like Security's got signatures for it. What if I like pack my malware? Like if I go and I pack that thing so that you can't see the code inside of it, then Security's signatures don't work anymore. And Securite is like, oh, it's okay. I got this. I got clever solutions for this. I'm gonna play in a sandbox now. So Securite is like, all right, everything's gonna happen in a sandbox now. I can now run your malware, execute it, and see what happens, rather than like thinking, oh, I can have like these byte signatures. I can start executing things inside of a sandbox and say, what does this piece of software do? And based on that, we'll make a decision about whether something's evil or not. So Voldemort's like, okay, but you got nothing. Like what about exploitation? Like I can exploit your own software and use it against you. Like I can do things like using Stack Overflows and other things. But Security is like, oh, no. We got this thing called DEP. We got ASLR. Now we got EMET. So Security keeps evolving like all of these protections to the point where Voldemort has to sit here and think like, all right, I can keep evolving my malware and making it more clever, or maybe I can do dumber things. Like maybe I can just do like derpy shenanigans and I can still get my stuff across. So as things have to evolve, like ROP chains are very difficult and like really advanced, packed, clever malware is very difficult. So Voldemort is, rather than doing those things, is saying, all right, maybe rather than working so hard to try and get in, maybe I'll do some stupid things. And that's kind of the genesis of this talk, is we want to get across the idea of like writing good, hard malware and getting in is getting more difficult over time. And what we're actually seeing is more shenanigans used, more like stupid things done rather than the original approaches, which are like, oh, just make harder and more interesting malware and write good exploitation chains and so on and so forth. Now it's a lot easier to do dumber things, and you can circumvent security products and make Security have a bad day, essentially. So with that being said, I'm going to hand off to Tyler, and he's going to tell you about shenanigans.
Good morning. So one of our first examples here, we have unlock me for a good time, password protected documents. This is something we saw a lot of Voldemorts out there starting going to. So his plan was basically, security products are analyzing these documents. I'm going to go ahead and just put a password on them and encrypt them, use like real cryptography for it. And people, when they get these, they're probably going to still open them because, oh, it's got a password now, so it's secure. So we're going to suspend all our disbelief, and now it's even more secure because it's got a password. So this is an example of a phishing document that we have here. And it's just kind of simple starting off. That the packet's finally ready for the person, and then they're including a password, and that'll be different in all the emails, different length. And so Security gets this, on her desk, and she starts looking at it. And a lot of things that researchers do, one of the first things, looking at virus total and just kind of see, get an idea about it. And this is like a year old or something, and on virus total, it's still like 0 of 50, whatever. So like nothing has said it's bad. So Security is like, okay, so our next step, using OLE VBA, that's like a common tool that a lot of malware analysts use to analyze macros and documents. It's a really fantastic tool. It'll dump out all the macros for you. So she's going through and analyzing it, dumping it. Okay, there's no macros. That's another good sign. We're looking pretty good here. But when the user gets it, you saw in that email, they get this request for payment. It just looks like a normal Word doc. They open it up, and they have to enter in the password before they actually even open the document. And here's Voldemort. He's real excited. I'm sure a lot of you guys recognize this image. This is like a really common image that a lot of these macro malware will use. So that looked bad, right? Like, oh man. So Security has to go back to the drawing boards and really figure out, what's going on with this. So she starts analyzing it in a tool like a Cerberus profiler, and she starts seeing all these encryption info, encryption summary information. And when we look into that, really the main thing that you're dealing with is this encryption info, and that deals with all the crypto for it, and then you basically just have like an encrypted zip file. So Security is like, okay, maybe I'll just crack these, right? And that's not going to work. Even like the older versions, it would take a lot of computation, and a lot of these were actually using the newer Office encryption. So it's actually like pretty good. So it would take a long time. So Security is back to the drawing boards. She's got the password. She's hacking away there, opening up the Visual Basic debugger, stepping through, kind of seeing what's all going on with this. And as she's going, she's able to see that it's just writing a Visual Basic script and then executing that. And then she sees that command.exe and ping is launched. So she's really pleased with herself. She starts analyzing the Visual Basic script. And then it's more of this garbage, right? And she's like, okay, we've got to go back to the drawing board. So she's going to start debugging the Visual Basic script. So you can do that with C script, and you just pass this /x argument to it. And if you have like Visual Studio installed, she can just be right back at it again. She's stepping through, debugging, trying to figure out what all this junk is. And at the end of the day, this is pretty simple what it's doing. There's an auto open, which a lot of macro malware we use just to trigger. Once macros are enabled, auto open will trigger all the code and start doing all the bad things. So what it's doing, that command.exe that we saw, it's actually just launching ping for a while to try to delay execution. So if things are in a sandbox, try to slow it down long enough that the sandbox will shut down and then think, oh, it's all okay. All it did was ping for a while. But a lot of times they'll ping just like the local host for a while, and this is kind of interesting, is pinging out to the internet. So if you guys doing like IR work or like in an enterprise, you see a host like pinging like 200 times out to the internet, it's probably something maybe to look at, unless, I don't know, lots of people do that. And then after that, what is it doing? It's just, all it is, it's so simple. It's just downloading an XOR encoded payload and then executing it. So Security is like, okay, I got that. So she's just going to download that. She could keep stepping through it and then bug her and do it like that, or maybe she just wants to do it in Python because it's easier usually when you're doing these kinds of things. So here's just like an example. She's just downloading it to a byte array, opening it, and then XORing it. So then she's got it out. She figured out, what it's all doing. And at the end of the day, what does she really need to do? She really just needs to extract the password out. Voldemort has to send the password with this document to get the users. So she just needs to be able to grab that password, and she's pleased with herself there. Oh, next example, we need to go deeper. Document inception. So Voldemort's plan here is a lot of users, we probably, if we work in an enterprise, we all train our users, right? Don't enable macros. That's bad. Don't ever do that. And then also, maybe he wants to get users to click some things and do things like not enabling macros. So here's an example of a phish that's doing that. They have a whole context they're setting up about GoDaddy, and then they're just including the doc file. So you get that, open it up, and Voldemort's not really in the image. That's just, he's going to show up like that on all of these. But you get these Sage 1 accounting, and then we see these these are actually just images that look like embedded document files. I'm sure a lot of us have seen that. A lot of people nowadays, they like embed documents in documents, and then you have to just double click it and open that. So that's what this looks like here. And in this example, you do actually need to enable macros, but there's other examples where they've just been embedding like a Visual Basic script and then telling users just to double click that, and then it's just executing the Visual Basic script. But for this example, you actually need to enable macros, and then you're just clicking these documents, right? So it's okay. But that's not actually a document. I don't know if you can see there in the top corner, it's probably a little bit of an eye chart, but there's this image click event in these macros. So like when those images are clicked, it's just calling this method, this xwjqb, and then that's kicking off all the bad things. Like in the other example we saw, auto open was, like traditionally what a lot of macro malware had used to kick things off. But here they're using this image click. And around the same time, a lot of people started using like this auto close event as well. So if you have a security product that's analyzing, you actually need to close the document in order to trigger out the malware. So like a real users are going to look at it and they're going to be like, okay, this is not what I want, and they'll close it, and then that actually triggers the macro. But this one, clicking the image does it. So Securities, back to analyzing. Can take you anywhere.
Credit yourself on that one.
Yeah. So this is .NET Fiddle. This is a great tool for analyzing macros. So usually there'll be, you guys saw those kind of really long strings and messy things. So it's easy to see where those strings are being used. Usually there's just a method that's calling those. So this is just a website. It's great. You can grab those string methods, just put them in there, and then just call it and write those out to the console. So at the bottom, we can see, like really easily without spending a lot of time, like wasting time debugging. And usually there'll be like really long for loops with big numbers and like jumping around. So it's easier just to grab those strings and look at it and, what are they trying to hide? And at the bottom there, it was printing out to console like what this is actually doing. So it's just launching a PowerShell command that's downloading a file and executing it. So it's super simple, but effective. So Security's response, she's going to make sure that she, like in a sandbox type example, make sure to close those, and then also like simulate human movement, like clicking any images that are in the files. So Voldemort's, he's like, fine, okay, you're figuring out, all these things. My next thing is I'm just gonna send people code and see if they just run it, because I don't know, people, right? So he's really excited about this. He's thinking, what would be a good thing to do? So JavaScript, right? It's like so commonly pervasive on networks. Like there's tons of JavaScript being sent over the network. So he's like, okay, JavaScript. And this is an example of a phish, and Voldemort's just like giving up with the social engineering. He's like, I don't even care, right? Like people are still gonna like unzip this and run it. So I think we're good to go here. So that was a kind of a famous campaign, the blank slate emails, they were called. So what they were actually doing, he was being even more crafty, right? It was a zip within a zip. And that's a JavaScript. So like if a security product wasn't doing like multiple layers going deeper, it wouldn't analyze this as well. So that's an example of the JavaScript. It's pretty short, and you'd analyze this in a similar way like you would looking at those macros, just using like a JavaScript debugger and then changing out evals. A lot of times they'll like put a bunch of stuff and decode it and then eval that, and it's just JavaScript code. So changing that to like write it out to the console. There's another really cool tool, malware jail, that'll actually execute them in like Node.js and like decode a lot of this like automatically for you. So, Security is analyzing that in kind of the same way. We don't need to go through that more, but it's basically the same thing, right? All these little simple things are just like delivery mechanisms, relying on people instead of some difficult exploit that's going to get patched really fast, or it only hits like certain users. So all it's doing is just going out to the internet, downloading something, and running it. So this is just an example of the requests that it generates. And this time, like, Voldemort just is not even caring. He's not even trying to XOR the payload and make it not look like it's being downloaded. So here you can see the PE header at the bottom in the data. So he's just giving up, downloading it and running it, and still working pretty well for him. So our next thing, Voldemort's he's got another plan. He wants to start attacking some Mac users, and he doesn't want to write a bunch of Mac malware because he maybe doesn't have a lot of experience with that. So he's just going to do a bunch of scripts, and he's gonna boop Harry on the head here. So this is an example of Eleanor. It was like a fake document converter. It doesn't really have any functionality. Like that image there is just for the users, just to make them think it's real. But this actor was using this made with this platypus, where you can just take a bunch of bash scripts basically and turn it into a native app. So if you guys haven't looked at like a Mac app bundle or analyzed like Mac malware before, you have this like kind of folder structure. So you have the contents, and then in the Mac OS folder, that's where the actual binary is. And that's where we have like the platypus, this easy doc converter binary. And then in the resources for this, we have just tons of scripts in here. You can see all kinds of things, save, script, shell, and then there's this info.plist, and that's usually a lot of metadata about it. So if we look at the script file, and that's actually what Platypus runs right away to start with. It's kind of interesting that it's actually doing a check to see if Little Snitch is running, and if Little Snitch is running, it's not going to do its bad things. So that's kind of interesting. I think we've seen that with like maybe a few other malwares as well, as they were just looking for like if Little Snitch was running, I'm not going to do anything more. And maybe like Voldemort's just trying to blend in a little bit more, because when this beacon's out, like the user, if they're running Little Snitch, they're probably a little bit more security aware, and then they're going to see that this bash script is trying to go out to the internet at some weird place. So it checks for that, and then it checks to see if it's already running as well with this checking for the file. So if snitch isn't found, then checking for this file. And then you can see like it's just like really simple. It's just all these like shell commands. They're copying files and executing them, changing permissions, even like just like said things. It'd just be like a user was down at the terminal and just typing things in. So super simple, but it works. And this is the agent file. So that was another script we saw in that directory. It's just another PHP script. This is the command handler. So you can see the different commands. It can get information with the get info in the top left, if that's not too small, executing a shell script, downloading a file, or doing an update. So, I mean, it's like 92 lines, right? And then you can implement pretty much whatever with that. Voldemort as well, as we'll see some more examples later on, he's getting maybe a little lazier or smarter, I guess, as a developer, just like copying, pasting things. So this is a web shell. You can see at the top, you even left like the comments in to leave the credit. And then we can see the password as well for the C2 server. So just more scripts, PHP scripts. And then this is the save. This is kind of interesting as well. It's just a bash script, and you can see it's just running a curl command that's posting the host name up on there. So really simple to implement. So Voldemort liked that. He had some success doing that with the copy and pasting thing. So here we are. We're going to look at some more examples of that, which is kind of interesting. So Voldemort's plan, it's taking him too much time to write things. He has to learn a lot to do it. So he's just going to copy pasta like every other developer, code via Stack Overflow. You'd be surprised like how much we actually see that. There's a lot of stuff. I mean, malware authors, Voldemort, he's a developer just like everyone else, like Googling for answers. So another Mac malware example here, since he had so much success with that. This was complex. It was a Sophisy Mac backdoor. And then here, when you run it, you actually get this little pop-up of this like rocket engine here. It's kind of like a decoy to make the user think everything's okay. It actually just opened a document. Nothing to see here. It's all good. So Voldemort, he doesn't want Security looking at his malware, so he's Googling on the internet, how can I see if somebody's on a Mac? How can I see if somebody's debugging? So there's this old Mac Q&A from like 2004, I think it was, and here it is. It's just checking, am I being debugged? We can see it's just like kind of really simple, just doing a syscall to figure that out. But this has actually been like reposted on several forums. I think it's used a few different malwares. So and then Security is analyzing it, and she can see this is the pseudocode for that. We can see like the symbols are still left in. It's like the exact same function name, MID being debugged. It looks a little bit different, when it's the pseudocode and compiled, but we can see a lot of the same things. So literally just copying, pasting. Then another thing Voldemort's doing here in Complex, kind of a simple anti-sandbox checks, just checking to see if they have internet. He's just trying to go to Google. And if that works, then they're going to continue on and do the bad things. If that doesn't work, so if like Sandbox didn't have internet access or an analyst was analyzing it locally, it just would do nothing. Here we have another example. Voldemort needs some fresh persistence. So this was another example from Sophisy doing office test persistence. There's a really great researcher, Hexacorn. He's got this awesome like running blog post of all these different persistence methods. And he came out with this one using this registry key, so then anytime Office is opened, it's going to load this DLL if you put this here. Or if you fill out that registry key and then with whatever you want. So after that, they started just using that. They're like, okay, that's a great idea. I'm just going to copy and use that. So here's an example that was something new that they were using. So he didn't have to really develop anything new. He's just kind of searching just like the rest of us. So next example, Voldemort wants some keychains. So this was kind of a cool one as well. It's like distributed as a zip file. It looks like a JPEG, but there's like a space at the end. So when you double click it, it actually executes a Mako in the terminal because there's no like file extension associated with it. And then he wanted that keychain stealing code. He wanted all the keychains. So literally just like copy and pasting. There's the GitHub link there, and he's using that to basically just like open up the keychain and decrypt it. So, Richard talked a little bit about the packers, and like it used to be like everyone's using all these really complicated packers and like all these crazy things, but a lot of that stuff, it just kind of makes things stick out anymore, to be honest. The more like complex and creative and kind of crazy things malware's doing, it just like, makes it like really stick out. Like that's not normal. So UPX is pretty common. A lot of like legitimate software developers use it, but Voldemort still wants to give Security a hard time. So actually, with like UPX, you can unpack it just using like the command line tool UPX-D, and then you specify the file, and it will auto unpack for you. It's pretty easy. But here's an example. They were just changing like the string instead of from UPX to whatever in there, and that actually just breaks that. So Security actually then has to debug in, find the original entry point of the code where it jumps to there, and then dump it from there. So I'll hand it back to Richard here.
So at this point, Voldemort's like, all right, I'm going to keep messing with Security. Like, I'm going to start doing things where I know that Security is starting to play in sandboxes and like virtualizing environments and trying to run malware out of them. So can I screw that up? Can I mess with that? So Voldemort comes up with like the cleverest of things where he's like, oh, I want to run this document. I want to make sure that if it's running inside of your sandbox Security, I'm not going to do any of my malicious intent. So he comes up with like a clever check. He basically says, hey, do you have documents you've opened recently? Because a normal like actual endpoint, like all of your computers that are sitting out there, those will have like you've probably opened documents. So in your recent docs, there's going to be a list of things. However, inside of a sandbox, inside of Security's sandbox, there's no opened recent documents because she's spinning it up every time and it's a brand new version of this VM. So Voldemort's like, I got you. I'm just going to check the number of recently opened documents and use that against you. So simple to fix, but like clever trick that Voldemort used with zero effort. Voldemort also was like, hey, maybe I'll do some user targeting. Maybe I'll focus on like what environment do I want to execute in. I'll check the username. I'll check who's running this. If it's like this very specific username that I know is associated with Security's Sandbox, I'm not going to run. Or if I know that it's not running as admin or so on and so forth, like I can pick exactly where I'm running from based on who's running it or based on the username if he's running it. So simple checks that Voldemort's using, but really effective in order to screw up Security's day. And like I said with the environment, like you can check BIOS, check file names of where things are running from and so on and so forth. So Voldemort's just like, I'm going to do some lulzy things that are real simple, and suddenly Security's Sandbox is just like, I ran the malware and nothing happened. Simple checks, but really effective. And like Tyler was talking about, there's a lot of things that you can steal from the internet. Like Stack Overflow is everybody's best friend. You can go and find this thing called PA Phish, which essentially is like, hey, am I running in a sandbox? And it's code that's written for you, and it's a long list of checks that will say, check all of these things because any of them returning true essentially means, yeah, we're executing from a sandbox. And Voldemort's like, I'll just shove that code into my software and make sure that like I'm not executing as a Security's Sandbox. Super easy and like zero effort. You don't have to spend any time with this. So that's basically all that we have in terms of like Voldemort's tricks and things that we wanted to cover here at 8:30 in the morning. We want to leave you with a quote from a coworker of ours that we feel like really epitomizes the reason that most of this crap works, which is this. This guy's his nickname internally is DoubleClick, and it's because he gets hit by every phishing campaign that we do internally. But the point of this being, all of these shenanigans and all where we're going these days is you can, no matter what, at some point there's still a user at the end of like a computer. Like you still have users using this computer, and it's a lot easier to exploit a user than it is to exploit like a computer. So what we're seeing, what Voldemort's doing is like this evolution of like, I should just take advantage of how dumb users are. Like they're gonna keep clicking on things. The fact that you can email somebody like, hey, can you double click this JavaScript for me? It's gonna be fine. That's stupid. Like it's really bad. But the fact that it exists and there's campaigns of this means users are that dumb. So it's good to understand that this stuff exists and will continue to exist. And we have to like continue evolving protections and work on these things in order to solve these problems. So with that, we'll take questions. Yep. So he's asking if we have any kind of like figures and statistics on like success rates of these different ways of getting in, essentially. That's what you're asking. I can't give you exact numbers. I would say the point that we could potentially make is we see these things used until they're completely unsuccessful. So we actually both Tyler and I work at Palo Alto Networks, and we actually see attackers evolve some of the like Voldemort's techniques evolve based on the protections that we write, which is kind of an interesting game that we end up playing because like we work for a company where like our crap's so prolific, the places where our software is so prolific that when we write new protections that block against a specific campaign, we actually see like malware authors go and say, oh, that's not working anymore, and then they change tactics. Giving you numbers is, I'd be completely making them up, so I can be like, yes, 100%. They'd be completely made up, so I don't have exact numbers.
Oh, I was just going to say, yeah, you'd probably have to have like the C2 server, right, to see that they're callbacks. But like Richard said, I mean, they wouldn't be doing it if it wasn't working. So, I mean, you'd think adding all these extra hoops for users to jump through would make it, like less successful, at least to some degree. But I don't know. I mean, it seems to be working well, so they're continuing with it. I mean, there's like a trade-off from maybe it gets through a little bit better, but then maybe some users don't do it. But I mean, some of it you can actually think of, like the password thing. Like I know a lot of users, like they'll say, oh, it looked like it was from security or it was secure. So like that's like a common like social engineering tactic, right? Is use security and people kind of suspend disbelief, like, oh, it must be legit. So.
Yeah. Sure. More questions? All right. Thank you, everybody.